8.7 volume of a sphere. This applies to the applied level grade 9 math course and the academic applied level, or academic grade 9 math course. And if you look over at Charlie, he looks sad because this is our last math lesson of the year. So let's do it. So I'm going to teach you a new formula for volume of a sphere. It's on your formula sheet. You've already got it written down. And our goal today is to use that formula. Okay? So here's the formula, 4/3 pi r cubed. You could write it this way, 4 pi r cubed divided by 3. Both of these mean the same thing. Okay? And depending on what problem you're solving and how, it might be more convenient for you to look at it this way or to look at it this way, and they both mean the same thing, and that's the most important thing that you understand with the fraction. So quick example, if you know the radius is 14, find the volume. Okay, pretty simple. Make sure you put the units, and you have to practice putting these in your calculator because there's a lot going on there. You got to be able to put pi. I'd rather you not put 3.14. You can, okay? You're not going to get the most accurate number. You should use the pi button. And so when I come around and ask you to show me your solutions, I am going to look for you to write to do the pi button. And then 14 cubed, and make sure you do that all proper in your calculator. Oh, by the way, just remember volume, the units are length or centimeters or meters, whatever, cubed. All right, here's the big problem, the last example problem of the new material for the semester. Certainly there'll be lots left on review, but we have a propane tank and see the shape of it. What it is then is it's kind of like a cylinder in the middle, but you've got, and this it's not drawn very well, but these should be 2 equal halves of a sphere. Okay, so imagine that this is just because it's drawn on on an angle. It's not head on, but this half from here to here is drawn is the exact same size as this half. Okay, and so this plus this, it says it has a semi-sphere on each end. That's because this plus this will be one full sphere. Okay, and then you've got a cylinder in the middle. So it says find the volume of the whole tank. So all you have to do is take the volume of this sphere that would have a radius of 40 centimeters. Okay, and you find that volume, and then you add it to the volume of a cylinder. So a couple of notes before, you've probably written them already, but you have to use either meters or centimeters. See how it says 1.5 meters and 40 centimeters? You can't, when you're doing a volume calculation or a surface area calculation and your measurements are in different units, you have to put them in the same one. And it's not clear here which one you have to use, because you could put it as centimeters. You could make this 1,500 centimeters. That would be fine. Or you could do them both as meters, which is what I chose to do. If you got this question on your exam or on an assignment or something, and you chose to do different than me, as long as they're both the same unit, the answer is just as correct. Okay? As long as you make it just one. So here we go. So finding part A, the volume. Let's just say VT is going to be my total volume, S is going to be the sphere, remembering that really just those two put together is a sphere, even though it doesn't quite look like it, and VC is the cylinder, which is the inside part. Okay, so just using the formulas, the total volume is the sphere plus the cylinder, which so 4/3 pi r cubed plus the volume of a cylinder is pi r squared h. Looks hard, eh? But it's not that hard. Just sub in r, and here's my h is 1.5 right from here to here, the height of my cylinder. And that's it. Find the answer. It works out to 1, which kind of seems funny because you think, well, that's 1.5 meters. How is it possible the volume's only 1? The reason, of course, is that it's not a full. It's only 40 centimeters. Oh, sorry, it's only 80 centimeters across. So it's not a full meter wide. Okay. So part A is done. Now here's a weird one. It says if you ship this thing somewhere, okay, and you had to stick it in a box, and the box, it was just going to be able to fit in the box. How do you find that's supposed to be? What are the smallest dimensions of that box? So, if you're going to put that thing in a box, okay, it has to have a length of 2.3 meters. And the reason I say that is it's got to be the length of the cylinder part plus each end, right? That's each end of the half sphere. So it's 2.3 meters this way. And then because the diameter of the tank is 0.8 meters, it's got to be 0.8 meters this way and 0.8 meters that way. Okay, so I'm assuming zero clearance. Perhaps if you could say a little extra space on each side, but say it's zero clearance, it has to fit just snugly put in there. So we know the width and the height, and we know this, and the volume of a rectangular prism is just length times width times height. So that's a pretty easy calculation. Okay. Then it just says the last part of the question is how much empty space. So you had this box, you put this thing inside. Well, the amount of empty space would just be the volume of the box subtract the volume of the tank, and that's how you get 0.47. Okay, and I think that's it. That's our last new lesson, and yeah, have fun with it.